Yes, good morning, Jai Hind to all. Today, myself is Nikhil Kumar. I am the faculty of IT department in Ajay Garg Engineering College. Today, we have the lecture on discrete structure and theory of logic. That is the code is the BCS 303, and it is basically the second year subject, IT and CSC allied branches. And we will cover the sets and relations in the last previous lectures. So we also cover the some most important points from the sets and relations. So we will continue on where we left. So we have covered what is the sets and these terms already we discussed. So we will discuss from the where we left. Okay. So in the last lectures, we discussed the points that there are some mathematical functions and the operators are used in the set relations. Let's suppose we have the set elements that is contains the set names A with some elements. Let's suppose A, B, C, D, E, and there are one more set is present here with the elements 1, 2, 3, 4, 5, 6. Okay, so basically in the set theory, we have some operations that are based on the symbols. That one is the union symbols, which contain at least two sets. So we have A union B and A intersection B. If we count the operators A union B, that means we include the values of A as well B. Let's suppose these sets are present. So what will be the value? We will continue all the elements that are present in the set A as well in set B. What's happen if we count A union A? Is it possible? Yes, it is possible to evaluate the values of A union A. That means we will totally present the values in A and second element set is also the A. So resultant value will be A. So in that case, the resultant value will be A, B, C, D, E. I will take one more examples that is based on the different operations. It is the union operations and this one is the intersection. So in the basically the intersection operations, what we will count, we will find out the set elements that are present in both the sets. Let's suppose set A and B have the some elements that is mentioned in the figure. This structures questions. So what we will take, we will check that the first element is present in second element or not. Let's suppose it is not present, then we will move to the next element and we will find that this B element is present in the set B or not. So here when we evaluate all the elements, then we will find that in set A and set B there is zero presence element that are common in both the elements, both the sets. So we will represent here pi. One more thing that is important and you should be noticeable, that if in set A and set B there are no any element is common, so we will write down the phi element. Phi means null values. When we indicate the phi values, we will not represent it with the usability of the, we will not mention this phi in the braces, because when we mention this phi in the braces, that means a single element is countable, that is phi, but here it indicates a null value. Okay, so it is very important that all time if we want to represent the phi value, that means null values, we will not represent the braces, we will not represent under the braces. Some more examples are there. Operators are there. A minus B. What does it mean? That means if let's suppose A contains some element and B contains some elements, so we will find out all the extracted elements that are present in A from the set B. So we will eliminate that element and the remaining elements will be mentioned in the resultant value. Let's suppose we will add on some elements. Now we will update this element, this set B with added one more element, that is A. So what will be the resultant value here in that particular case? When we remove all the elements that are present in B from the set A, So the remaining element will be the B, C, D, E. Okay, why we eliminate A? Because A is present in the set B. One more thing that is noticeable, that here A and A both in the set is also represented by the capital A, and here this is the set element. But the difference between lowercase and uppercase, so it is very mandatory to follow that the rule concept is that if you indicate the set element to represent the set element with the capital, most probably it is written in the capital words, and the elements that are mentioned in the set elements, it is represented in the lowercase. So basically, if let's suppose the set elements are represented in the uppercase, so you will write down every time when you, any operation is performed in the set theory with the uppercase. But here in this particular case, the set elements are mentioned in the lowercase, so we will use as it is as the lowercase. So it is possible that the same element, that is A is mentioned in a set element, but we will check that which one is the uppercase and which is the lowercase. Okay, so we will continue with the next questions. Yes, such type of questions can be solved out using the two methodology. First one is the Venn diagram, second one is the formulas based. So how we will solve out? We will try to solve this question by the using the Venn diagram. So what the question say? In a survey of 80 pupils, 50 like tea, 30 like coffee, and 10 like both tea and coffee. Find out how many people like only tea, liked only coffee, and like neither tea or nor coffee. So how we will solve out? Firstly, we will prepare the Venn diagram. These are the persons who like the tea, and this one is who like the coffee. So 50 likes the tea and 30 like the coffee, and 10 like both tea and coffee. That means that these elements choose the tea and coffee. Find how many pupils like only tea. So in that particular case, only tea, how many students are there who only likes only tea? That means 50 minus 10, that means 40. In that particular case, only the persons who only likes coffee, how many persons exist? That means 30 minus 10 equal to 20. Why we use 30 minus 10? Because these 30 elements are those who like coffee as well as tea also, maybe exist the tea also. So but in particular case, when we count the elements who only likes only coffees, so we will eliminate the teas like persons. So we eliminate 30 minus 10 equal to 20. Like neither tea nor coffee. So how we will calculate? Total elements are, total students, total pupil are 80, neither tea nor coffee. That means we will find out 80 minus this 10 minus 40 minus 20. 40, 20, 60, then 10, 70. That means total number of persons that doesn't like tea or coffee, that are the 10. So we will calculate the number liked person, the persons that that like the only tea, that are 40, and the persons that only like coffee are the 20, and the persons that neither tea never like tea or nor coffee are the 10. So using such Venn diagrams, we will calculate the resultant value as per the given question. But the questions sometimes may tricky, and you will calculate, you will ask in the questions how many total number of persons are exist, or number of persons that are like the tea and coffee or both. So you will evaluate the as per the given questions, we will evaluate the resultant value and change the concept. The Venn diagram will be same for all the cases. Such questions may vary just like on the behalf of the content. Here in such questions, tea, coffee and common like both the case are exist. Sometimes such questions exist that some student like Hindi, some student like English, some student like Punjabi, and number of persons that like Hindi and English, and like Hindi and Punjabi, and English and Punjabi. So how many student like trio subjects? So such type of questions will vary as per the given content, but the concept will be similar. So I mentioned some of the questions. You can find out the resultant value as per your own, like you will have the same concept as mentioned here. So here is the next one approach. We will mention some questions to calculate the resultant value. We will follow these questions as per the given last questions. Now we come to the next questions, and the question is that let U, that is the set U, contains some elements that are finite in nature. So we will not maintain all the elements because if the set value will be lies too much. So U a set contains all the element that belongs from the range 1 to 100, and the next set A contains the element that where X belongs to U, X is divisible by 2. Okay, X, the set B contains the element which have the functioning that divisible by 5, and C contains the element divisible by 7. So you have to find out the number of operators, apply that operations that are mentioned here. So firstly, what we will do for in these particular questions, firstly we will write down the set elements here 1, 2, 3, 4, 5 up to 100. Now set A contains the elements which are mentioned. X is divisible by 2. That means the set from the set U. So what are the elements that are belong from such here? In that particular case, the element will be 2, 4, 6, 8, 10, 98 and 100. And set B R is divisible by 5. So 5, 10, 15, 20, 90, 95 and 100. And set C contains the set elements that are divisible by 7. That means 7, 40, 21, 28, 98, because we know that 14 7 is 98. So we will write down the last element. Because we have the range decided in the set U that the element belongs to 1 to 100. So in that particular case, the last element that belongs to in such range is 98. 14 7 is 98. So the first operations are A union B union C. So what are the elements that are common in that particular case? Firstly, that are the mode operations. So we will count the number of operators, the number of elements that exist in such case. So firstly, we will find out the number of elements that are belongs to in this particular case. What are that? 2, 4, 6. The element belongs to A union B, A union B, union C. Now, number of elements that belongs to A union B are 5, 10. No, 5 will not be present here because 5 are not the 5 will not belongs to vary in that particular case. So we will element 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. Okay, and now we will consider the union of C. When we count these set with the union of C, the resultant value will lie between 70. The only element that belongs to in such range are the 70. So the only element are the 1. That is a mode operator that will calculate the number of elements that exist in such operators after apply the operations. So the only element are existing 1. So we can calculate these two operations using that procedures. So now we come to the next topic. Next questions. Yes, this is very most important. A symmetric difference B. What does it means? That means A union A intersection B means A union B minus A intersection B. How we will represent such formations in the pictorial representation using the Venn diagrams? Just come to the topic that let's suppose there are two sets A and B, and some portions are common in both the sets. So when we calculate A union B, what does it means? The common values. A union B means the number of elements that are present in the both the and A intersection B means minus the elements that are not present in the A intersection B, and this was the common elements. So basically when we count A union B, that means the all occupied figure that have the shaded portions, and these intersection portions cover the double shaded portions. So when we count A union B minus A intersection B, then we have the portions that are less shaded. So the resultant options are just like, so this is the resultant of A symmetric difference B, where this is A, this is B. Okay, so using the operators of the asymmetric difference B, we will calculate here by the Venn diagram that what are the element will be covered in the asymmetrical difference B. So we will, how we will calculate? Firstly, we evaluate the values of A union B, then A minus B. A delta B using the first question number 11, A union B minus A intersection B. Firstly, we will calculate A union B, then the resultant value will be 1, 2, 3, 4, 5 and 6. A intersection B means the common portions. What are the common portions? 3, 4. 3 and 4 are the common portions. So we will evaluate the 1, 2, 5, 6. So from the given question 11, the resultant value will 1, 2, 5, 6. So when we calculate the symmetric difference, that is the operator is the delta, so the resultant values will exist, that have the resultant, the formula A delta B, that is the asymmetric difference B, equal to A union B minus A intersection B. So you can find out the resultant value A delta B by using this formula. So in the next video lectures, we will cover the relations from the set elements. So thank you guys for attending this video lectures. In the next lecture, we will discuss some more examples with the relations. relation in the set theory.